The only reason to measure anything is to gauge how much it's changing. So the average rate of change can tell us how a function is changing. The average rate of change of a function f of x on an interval from a to b is the quantity f of b minus f of a over b minus a. So if I were to draw a graph, maybe I have a function on the interval from a to b. Maybe the graph goes like this. The height here is f of b, and the height here is f of a. The average rate of change, graphically, tells us the change in the y value. So f of b minus f of a, that's this height here, and this is the change in y value. And b minus a, that's the change in x value. So the average rate of change gives you the change in y value divided by the change in x value. That might remind you of slope, and indeed, the slope of the line that passes through these two endpoints is the average rate of change, rise over run. Let's see a concrete example. Let's do this function. So let f of t be the temperature in San Luis Obispo on July 4th. So I'm going to make this temperature up, but let's say this graph gives you the temperature in San Luis Obispo on July 4th. Maybe at midnight, I'll say that's time 0. It was 50 degrees in San Luis Obispo. Maybe by the time it got to be 12 hours later, it was, let's say, 86 degrees in San Luis Obispo. And at midnight on July 4th, so 24 hours later, let's say it was, I don't know, 74 degrees. And throughout the day, the temperature fluctuated in this manner. So here's a graph of the temperature in San Luis Obispo on a certain day. The average rate of change on, let's say, the interval from 0 to 24 is how much the temperature has changed divided by how many hours it's taken to change. So it's gone from 50 degrees to 74 degrees over the span of 24 hours. So it would be 74 minus 50 over 24. So I think that is 1, isn't it? 1. That means, on average, throughout the day, the temperature has changed at about a rate of 1 degree an hour. So this is temperatures in degrees, so this answer is 1 degree per hour. So it's how fast the temperature is changing on this interval. You could also say, what about the average rate of change for this function? Let's say from hours 0 to hour 12. Well, in this time span, it's gone from 50 to 86 degrees. So 86 minus 50, that's the change in temperature. And it's only taken 12 hours to do that. So what is that? That is 3 degrees an hour. So on this interval, its temperature is increasing faster, about 3 degrees an hour. What about the average rate of change from hours 12 to 24. So from hours 12 to 24, it decreased temperature. So I'm going to say the average rate of change is 74 minus 86 over 12, and I believe that is -1 degree an hour. So the temperature is decreasing. The slope of the line passing through these points is -1 degree an hour. Let's do one more example of average rate of change and what it means. So let's suppose you drive from San Luis Obispo to Los Angeles, and it takes you 3 hours. So let f of t be the distance driven after 3 hours. So I'm going to try to draw a semi-reasonable graph of what this function f of x might look like. So here we are. So I'm driving for 3 hours. So 1, 2, 3. There's hour 1, hour 2, hour 3. And at time 0, I haven't driven any distance, so my function is 0 there. Maybe after 1 hour, I've driven maybe 70 miles. After 2 hours, I've driven maybe 100 miles because I stopped for a snack in the middle. I didn't necessarily go as fast as I could go. And then maybe 150 miles after 3 hours. So here is maybe a graph of how far I've driven after a certain time. So this is my f of t. So what is the average speed that I've gone? So the average speed is f of 3 minus f of 0 over 3 minus 0. So 150 over 3, which is 50. I guess these units are in miles per hour. So on average, I've gone 50 miles an hour. Even though at some points, for example, the average rate of change for hour 1 was 70. So I went 70 miles an hour on average during the first hour, but over the entire time period, I averaged 50 miles an hour. Now I'll end this very brief introduction to rates of change with the observation that the rate of change for a line, so let's say my function f of x is a line, mx plus b, the average rate of change for a line is the slope m. Why? Well, this is easy to see because if I do f of b minus f of a over b minus a and b could be any real numbers you like, you get f of b, which is m times b. Actually, I'm using b in two different contexts here. I just noticed that. So let me change this function to mx plus c, just so I don't get this c and that b confused. So if I plug in x equals b, I get mb plus c, and I subtract f of a, which would be m times a plus c, all over b minus a. And if you notice, I get mb minus ma, the c's cancel, over b minus a, which simplifies to just m. Okay, so there's a very brief introduction to average rate of change. Excellent.